Most units in chemistry are really straightforward and simple. The units that tend to cause people trouble are those that are derived, those that are based on other units. The easiest way to explain the problems that you can encounter with derived units can be illustrated best by simply looking at volume. One would assume that 1 cubic centimeter would be equal to 10 to the negative second cubic meters. It turns out, however, that that's 100% wrong. The reason that's 100% wrong is because it's a derived unit. When we say we have a cubic centimeter, what are we really saying? We're saying that we have a cube and that cube is 1 centimeter by 1 centimeter by 1 centimeter. Alright, so my cubic centimeter would be a cube that's 1 centimeter by 1 centimeter by 1 centimeter. Well, we know when it comes to linear units that 1 centimeter is 10 to the negative second meters. So my same cubic centimeter would be 10 to the negative second meters by 10 to the negative second meters by 10 to the negative second meters. In other words, 10 to the negative second meters times 10 to the negative second meters times 10 to the negative second meters, or 10 to the negative 6 cubic meters. Therefore, it's obvious, looking at our experiment here, that 1 cubic centimeter is actually equal to 10 to the negative 10 to the negative 6th cubic centimeters. Okay, so one cubic centimeter is 10 to the negative 6 cubic meters. Mathematically, if you think about what we were doing down here, we were multiplying 10 to the negative second meters by itself 3 times. And you can write that operation of multiplying by a number by itself 3 times as cubing it, which, hey, is exactly what we did to the units. As a matter of fact, ten to the negative 6 is the same thing as 10 to the negative second cubed. What that means is, and what I'm trying to communicate here, is you don't have to draw cute little boxes whenever you want to know a cubed relationship for volume between two things. For example, if I want to know the relationship between cubic picometers and cubic meters, all I have to do is write the linear relationship. And then cube the linear relationship. In case you've forgotten, 10 to the x raised to the y power is 10 to the x times y power. So, one cubic picometer would equal 10 to the negative 36 cubic meters. Now, this only deals with derived units of volume. You only have to sweat the derived units. Liters work like you normally would expect them to, meaning that 1 milliliter is still equal to 10 to the negative third liters. So liters still work normally. It's only those cubic centimeters, cubic meters that you have to worry about, and you actually have to cube the linear relationship. Liters work exactly as you'd expect because a liter is a defined unit of volume. You do, however, have to know the relationship between the derived units and liters. All right, you need to memorize the pathway between liters and cubic meters and cubic centimeters. That pathway that you have to memorize is 1 milliliter is equal to 1 cubic centimeter. Not only that, but in the medical profession, they also call a cubic centimeter a cc. And that dates back to the days before before word processors, where they couldn't do superscripts easily, so they'd simply go cc for cubic centimeter. So when next time you listen to a medical show and somebody hollers for 100 cc's of glucose stat, you wonder why somebody's calling for 100 milliliters of sugar. But that's one of the pathways you're responsible for memorizing. You have to memorize this. If you don't memorize it, your entire existence will wind up being miserable in whatever career you go into. One that would also be helpful, but not quite as crucial, is 1 liter is 1 cubic decimeter. 1 liter is 1 cubic decimeter. That's another one that's helpful to know. That also means, just in case you're wanting to have something fun to talk about at parties, is that 1 liter is 10 to the negative third cubic meters. Know what's also fun to talk about? Kaboom! Why don't you write down kaboom? K-A-B-O-O-M. Kaboom! How many cubic micrometers in 3.45 times 10 to the 6 cubic meters? In order to work this problem, we need a conversion factor between cubic meters and cubic micrometers. You haven't memorized one. We have, however, memorized the linear relationship. We've memorized that 1 micrometer is 10 to the negative 6th meters. So to get the cubic relationship, we cube the linear relationship. That gives us 1 micrometer equals negative 6 times 3, or negative 18 cubic meters. So now we have our conversion factor and we can now work our problem successfully. I have cubic meters. Place cubic meters where they'll cancel out. We're left with micrometers. Multiply everything on top, divide through by everything on the bottom, and we get 3.45 times 10 to the 24th cubic micrometers. Chemistry's easy, life is hard, yes? Up a notch. How many liters in 6.78 times 10 to the 9th cubic micrometers? Well, we definitely don't have any relationship between micrometers and liters that we're aware of. We do, however, know the relationship between cubic micrometers and cubic meters. We know the linear relationship is 10 to the negative 6th, so we can cube it. And that's an 18, in case you can't remember. I'm going to make that better. There we go. All right, so that's one relationship we know. We also remember, have memorized, that 1 milliliter is the same thing as a cubic centimeter. I know the relationship between cubic centimeters and cubic meters. How do I know that relationship? Because I know that 1 centimeter is 10 to the negative 2nd meters. So I cube it, and I get 1 cubic centimeter equals 10 to the negative 6 cubic meters. So now I have 3 relationships that I'm interested in. Let's clean things up just a little bit here. And let's add, now that we've cleaned up our work a little bit, let's add one more unit conversion. We also know that 1 milliliter is, of course, 10 to the negative 3rd liters. Remember, with liters, because they're born units of volumes and defined units of volumes, their prefixes work normally. We don't do any cubes or anything fancy with the liters themselves. All right, so now we have everything we need to begin work. I've got my cubic micrometers. I don't want cubic micrometers, so I'm going to place them where they cancel out. I don't want cubic meters, so I'm going to place them where they cancel out. I know a relationship between cubic meters and cubic centimeters. So now I have cubic centimeters. And I remember that cubic centimeter is the same thing as a milliliter. So I can write this step if I want to. Or I could actually just say, hey, that's the same thing, right? His friends call him cubic centimeter, his parents call him milliliter, right? Either way would work, but we've gotten rid of cubic centimeters and we have milliliters. We want liters. We know that 1 milliliter is 10 to the negative 3rd liters. So now we're going to multiply everything on top, divide through by everything on the bottom. And when we do that, we wind up with, let's do this real quickly, 9 minus 18 minus a negative 6 minus 3. So that's a negative 9 plus 6 is a negative 3 minus a 3 is a negative 6. So our answer would be 6.78 times 10 to the negative 6 liters. Chemistry's easy, life is hard.